Pakistan spends roughly $10 billion a year on its military. That number gets reported, debated, and compared to India's budget every time tensions rise. But there is another number that almost never appears in those conversations: the estimated total cost of building, maintaining, and hiding a nuclear arsenal that now contains somewhere between 160 and 170 warheads. Some analysts put the cumulative investment, going back to the 1970s, at well over $20 billion. Others say that figure is conservative, that money did not build one facility. It built a system designed specifically so that no single strike, no single intelligence failure, and no single act of betrayal could destroy everything at once. Pakistan became a nuclear power in 1998, when it conducted 6 underground tests in the Shagai district of Balochistan. The world had suspected for years. The tests confirmed it. What the world still does not fully know, what American intelligence agencies openly admit gaps in, is exactly where those weapons live right now. This is not an accident. It is a policy. The Pakistani military has spent decades constructing what defense analysts call a dispersal architecture. The core idea is simple: never keep everything in one place. Warheads, delivery systems, and fissile material are stored separately, moved on unpredictable schedules, and housed in facilities that range from hardened underground bunkers to sites disguised as ordinary military installations. Some locations are believed to be built into mountainsides. Others are reportedly hidden beneath civilian-adjacent infrastructure in ways that make a targeted strike politically and logistically complicated. The budget behind this system is almost impossible to audit from the outside. Pakistan's official defense spending does not break out nuclear costs as a separate line item. The Strategic Plans Division, which controls the arsenal, operates with a level of financial opacity that frustrates even allied governments. Estimates from independent research organizations vary by billions of dollars depending on methodology. What is not in dispute is the trajectory. Pakistan's arsenal has grown faster over the past 15 years than that of any other nuclear state. At current production rates, it could surpass France and the United Kingdom in total warhead count within the next decade. A country of 240 million people, with a fragile economy and recurring political crises, is quietly building one of the largest nuclear stockpiles on Earth. And most of it is somewhere no satellite has ever clearly seen. To understand why Pakistan's arsenal is so hard to find, you have to understand one foundational decision made early in the program. A nuclear weapon is not a single object. It is an assembly of components: a fissile core, a conventional explosive trigger, an arming and firing system, a delivery mechanism. Each of those components can be stored in a different location, hundreds of miles apart, and only brought together under specific conditions. Pakistan took that principle and built an entire national strategy around it. The doctrine is called demating. Warheads are kept separate from their delivery systems as a matter of routine. A missile sitting in a storage facility is not armed. The component that would make it a nuclear weapon is somewhere else entirely. This creates a significant obstacle for any adversary trying to map the arsenal. Finding the missile tells you almost nothing. You would need to find the warhead, and then you would need to find the fissile core, which may be stored separately from the warhead itself. From a safety standpoint, Pakistan presents this as responsible stewardship. The logic is straightforward. A weapon that cannot be quickly assembled, cannot be accidentally launched, cannot be seized and immediately used by a non-state actor, and cannot be destroyed in a single preemptive strike. The dispersal is the protection. From an intelligence standpoint, it is a nightmare. American spy satellites can image a facility. They can count vehicles, measure construction activity, detect unusual heat signatures, and track patterns of movement over time. What they cannot easily do is distinguish a hardened storage site containing a warhead component from a hardened storage site containing conventional ammunition. Pakistan knows this. The camouflage is not just physical, it is categorical. Sites are built to look like things they are not. Movement compounds the problem. Pakistan is believed to transport nuclear components by road, using convoys that blend into normal military traffic. The vehicles are not marked, the routes change. The schedules are irregular by design. Intercepting intelligence about a specific shipment requires not just satellite coverage but human sources inside a security apparatus that Pakistan's inter-services intelligence protects with exceptional aggression. The result is a map with a great deal of blank space. Analysts can identify probable regions, known military zones, and facilities that show the right signatures. But probable is not certain. And in nuclear planning, the difference between probable and certain is the difference between a strategy and a gamble. Pakistan built a weapon that is difficult to use against it precisely because it is difficult to see. There are things the open record does tell us. Not everything is hidden. Some facilities have been identified through decades of satellite analysis, defector accounts, academic research, and occasional admissions from Pakistani officials themselves. The picture is incomplete, but it is not blank. Kahuta, located about 30 kilometers east of Islamabad, is where the program began in earnest. The Khan research laboratories were built there in the late 1970s under Abdul Qadir Khan, the metallurgist who became the architect of Pakistan's bomb. Kahuta housed the uranium enrichment centrifuges that produced the fissile material for Pakistan's first weapons. It remains an active facility today, heavily guarded, surrounded by restricted airspace, and sitting close enough to the capital that any military strike on it would constitute an act of war against the Pakistani state itself. That proximity is not coincidental. Sargodha, in Punjab province, is one of the most significant known nuclear-related air bases. It has been associated with the storage of nuclear-capable aircraft and, by extension, the weapons those aircraft would carry. The Mirage and F-16 aircraft based there are among Pakistan's primary air-delivered, nuclear delivery systems. Satellite imagery analyzed over the years has shown underground facilities and tunnel entrances consistent with weapons storage. Pakistani officials have never confirmed specifics, but they have never seriously disputed the characterization either. Masrur Air Base near Karachi represents a different kind of concern. It sits in Pakistan's largest city, a metropolitan area of roughly 17 million people. The presence of nuclear-related infrastructure in an urban environment raises questions that go beyond military strategy into the territory of accident risk, emergency response, and what happens to a facility like that during a period of serious domestic instability. Kirana Hills in Punjab has appeared in multiple analyses as a site where underground storage may have been developed inside natural rock formations. The geology there provides exactly the kind of shielding that makes a facility resistant to both surveillance and conventional attack. Then there is Akro, Pano Akil, and a constellation of smaller garrisons whose names appear in research papers with varying degrees of confidence. Some are almost certainly active. Others may be decoys, or may have been active at one point and since relocated. That last possibility is the one that keeps analysts awake. A site you identified 5 years ago may be empty today. The arsenal moves. The map ages. And the sites you have not identified yet are the ones that matter most. Building a nuclear storage site is not simply a matter of digging a hole and posting guards. The engineering requirements are specific, expensive, and in many ways self-revealing. This is precisely why so much effort goes into disguising the construction process itself. The baseline standard for any serious nuclear storage facility is hardening against conventional attack. That means reinforced concrete walls measured not in centimeters but in meters. Blast doors weighing tens of tons. Structural geometries are designed to redirect rather than absorb the energy of a nearby explosion. The facilities Pakistan has invested in most heavily are believed to be tunneled directly into mountainous terrain. There, the rock itself provides shielding that no amount of poured concrete can fully replicate. Kirana Hills sites and facilities in the broader Punjab and Khyber Pakhtunkhwa regions benefit from geology that adds hundreds of meters of natural overhead protection. Underground construction of this kind leaves signatures. Soil displacement, ventilation shaft openings, access road patterns, power line routing, and the movement of specialized construction equipment all show up in satellite imagery if analysts know what to look for. Pakistan's response to this has been methodical. Construction at sensitive sites frequently happens in phases spread over years, minimizing the visible footprint at any single moment. Spoil, the excavated material, gets dispersed across wide areas rather than piled near the site. Ventilation systems are designed to exit at distances from the main facility, breaking the visual connection between the shaft and what lies beneath it. The surface infrastructure is built to mislead. Ordinary-looking warehouses, vehicle maintenance facilities, and administrative buildings sit above or adjacent to what may be hardened underground storage. The goal is to make the site look like 100 other military installations scattered across Pakistan's landscape. Without prior knowledge of what to examine, an analyst reviewing imagery has no obvious reason to flag it. Physical security layers at known and suspected sites are formidable. Perimeter fencing runs multiple lines deep. Motion sensors, ground radar, and camera networks cover approach corridors. Armed response units are stationed permanently on site rather than available on call. Access control for personnel involves biometric systems and compartmentalized clearances. This means most people who work at a facility have no knowledge of what the most sensitive sections contain. The transportation infrastructure connecting these sites is engineered with the same philosophy. Roads serving nuclear-associated facilities are often built to handle heavy loads without appearing unusual from above. Rail connections, where they exist, are routed through terrain that limits observation angles. Every visible element is designed to tell the wrong story. The same features that make Pakistan's arsenal hard to find make it hard to secure. That tension sits at the center of every serious analysis of South Asian nuclear risk, and it does not resolve cleanly in either direction. Start with the insider threat. Pakistan's nuclear security apparatus is built around a concept called the Personnel Reliability Program, a continuous vetting process designed to identify and remove anyone whose loyalty, mental state, or financial situation makes them a potential risk. The program exists because the threat it is designed to counter is real. In a workforce of thousands spread across dozens of facilities, the statistical probability of radicalization, coercion, or simple corruption is not zero. It has never been zero. Pakistan's own military has experienced infiltration by extremist networks at multiple points over the past 2 decades. Several high-profile attacks on Pakistani military installations, including the assault on the Mehran Naval Base in Karachi in 2011 and the attack on Kamra Air Base in 2012, demonstrated that hostile actors had detailed knowledge of facility layouts and security routines. Neither Mehran nor Kamra is confirmed as a nuclear storage site, but both are facilities where nuclear-capable assets operate. The question the attacks raised was not whether the perimeter could be breached. The attacks proved it could. The question was how close a more targeted operation might get. The dispersal strategy creates a second category of risk that receives less public attention. When weapons components are separated and stored across multiple locations, the chain of custody becomes more complex. More people handle more pieces in more places. More transfers happen on more roads. Each link in that chain is a potential point of failure, not necessarily through hostile action, but through the ordinary mechanics of human error, miscommunication, and institutional breakdown. Pakistan's civilian government does not fully control the nuclear program. The Strategic Plans Division answers to the military chain of command, and the military's relationship with the civilian government has been, to put it diplomatically, inconsistent. 3 military coups in Pakistan's history. Multiple periods of de facto military rule without formal coups. A constitutional structure in which the army operates with significant autonomy on national security matters. In that environment, the question of who authorizes nuclear use and under what circumstances is not a settled legal question with a clean answer. A weapon, hidden well enough that enemies cannot find it, is also, in certain failure scenarios, hidden well enough that its own government cannot account for it. The uncomfortable reality of nuclear deterrence is that it depends on uncertainty functioning as stability. The theory holds that if no one can confidently destroy another country's arsenal in a first strike, no one will try. Pakistan has built its entire posture around making that first strike calculation impossible. In that narrow strategic sense, the secrecy works exactly as intended. But uncertainty cuts in more than one direction. When American planners wargame a scenario involving rapid escalation between Pakistan and India, and those scenarios have been run many times, with increasing urgency since both countries tested weapons in 1998. The problem that consistently resists solution is not firepower. It is geography. Where are the weapons? Which sites are active today versus which sites were active 18 months ago? If a crisis develops in 72 hours, which facilities matter and which are empty shells? The answers to those questions determine whether de-escalation is possible or whether a conflict crosses thresholds that cannot be uncrossed. India faces the same problem from a different angle. Its military doctrine has historically included options for rapid conventional strikes against Pakistani territory in response to a major terrorist attack traced to Pakistani soil. The two countries came close to that threshold in 2001 and again in 2019. Each time, the nuclear dimension imposed a ceiling on conventional escalation. But that ceiling only functions as a stabilizing force if both sides have enough information to make rational calculations. When the location of the weapons is genuinely unknown, rational calculation becomes difficult. Decision-makers fill gaps in intelligence with assumptions. Assumptions under pressure become the raw material of catastrophic miscalculation. The United States has provided Pakistan with nuclear security assistance, equipment, training, and systems designed to prevent unauthorized use and improve command and control. The full extent of that cooperation is itself classified. What is known is that it has been a source of friction within Pakistan, where any American involvement in nuclear matters triggers deep suspicion about sovereignty and ultimate control. So, the situation at the end of all this analysis is roughly the following. One of the world's fastest-growing nuclear arsenals is distributed across a country of 240 million people, managed by a military with a complicated relationship to civilian oversight. This is in a region where two nuclear-armed states have fought 4 wars and continue to exchange fire across a contested border. The sites are hidden. The map is incomplete, and the cost of being wrong about what is on it is measured in cities.